Anatomy of a Volcanic Eruption by Amy Jane Leavitt. So as far as you can see is the cover is that you see what looks like a red something with stuff spewing out. Everything behind it's gray. The next is going to be our table of contents, and it just tells us what each chapters are about, the directions of things. Here's the view of our table of contents that you guys have. Okay, so page 4. Eruption of the, I can't even say that word, Ivajivaljoku. It's a small earthquake shook Iceland's southern coast for 4 months. Then on March 21st, 2010, lava began to flow from that Ivajivaljoku volcano. By April 14th, another vent opened in the volcano. Magma inside this volcano pushed its way through the dense rock and thick ice cap. Lava began to pour out. Gas and steam shot tens of thousands of feet high into the atmosphere. Lava spewed from the volcano's crater and melted the mountain glaciers. Water rushed down the mountainside. It flooded farmlands and wiped out bridges and roads. Darkness covered the area most of the day. I want to point out here that the words lava, magma, and crater, the ones that are highlighted, their definitions are down here in this little text feature section. So let's turn the page. Airports all over Europe closed after the eruption of Ivajivaljoku. Thick ash clouds made it difficult for pilots to see. Ash also damaged jet engines. Approximately 100,000 flights were canceled. 10 million passengers were left stranded until air travel resumed on April 20th. It was the largest and longest airspace shutdown since World War II. World War II was from 1939 to 1945. As you see here again, these ash clouds and eruptions, and this text box is here. If you are on day 1, you don't have to go past this part, and I'm going to say stop because I'm going to read on. So if you are on lesson 1, you can stop and come back to this. Okay, so now we're moving on to our lesson 2. We're going to read pages 6 through 13. A volatile planet. Earth and its many layers. The Earth we can see is a rocky planet covered by vast oceans and planets. That, however, is just the visible part of the Earth. The planet is made up of layers which vary in thickness and makeup. So one such layer is the crust, and you see it here. And we've already had a definition, I believe, of the crust. The top layer of Earth is called the crust. Earth's crust is made of solid rock. The crust is Earth's thinnest layer. It varies in thickness depending upon location. On the continent, the crust ranges between 19 and 37 miles. In thickness, the crust underneath the ocean can be as thin as 3 to 6 miles. Earth's crust is made up of a large piece called plates. These plates fit together like a jigsaw puzzle. Mantle. The mantle is the layer directly beneath the crust. This layer is about 1,800 miles thick. The mantle makes up about 84% of the volume of the Earth's interior. The upper part of the mantle is made of particularly melted rock called magma. The rocks and magma in the mantle move in circular patterns when they are heated and cooled. These movements are called convection currents. And down here it tells you what convection currents are. They're circular motions in a liquid caused by heating and cooling. Core. The core is divided into an outer core and an inner core. The outer core is liquid, the inner core is solid. The tremendous amount of pressure in this inner core squeezes the atoms together to form a dense, solid material. The core is about 2,175 miles thick. And it shows you here. Scientists can cut into the Earth to find out what it looks like on the inside. One way they can learn about Earth's interior is by studying seismic waves. These are waves that occur during earthquakes. We learn about these waves in the book Earthquakes. Where plates meet. The plates that make up Earth's crust float on top of the mantle like ships at sea. The plates move because the mantle's rocks are constantly in motion. They don't move quickly, but they move enough to cause changes in the Earth's surface over time. Some plates move towards each other. These are called convergent plates. Convergent plates. When two plates collide, the denser one moves underneath the lighter one. That's what happens when an oceanic plate collides with a continental plate. The oceanic plate goes underneath the continental plate. Earthquakes are common at these plate boundaries because of the stress caused by the collision. The solid rocks of the oceanic plate partially melts into the magma as it moves deeper into the mantle. This magma is pushed up into the continental plate and forms a volcano. Many volcanoes are found along convergent plate boundaries. Oh, and here's the Ring of Fire. We're going to learn about the Ring of Fire. Ring of Fire. One of the most famous convergent plate boundaries on Earth is found in the Pacific Ocean. It is where the Pacific Ocean plate meets with all of the continental plates surrounding it. This area is called the Ring of Fire because more than 450 volcanoes are found there. In fact, 75% of the world's volcanoes on Earth are found in the Ring of Fire. And it says Mount Fuji in Japan is part of the Ring of Fire. Where plates pull apart. Some adjacent plates do not move together towards each other. Instead, they pull away from each other. These are called divergent plates. Divergent plates. When the two plates pull apart, they leave a space between them. This space is quickly filled with magma. It creates a new area of land called a ridge. And here you see how it's creating the ridge in the divergent plates. If the magma pushes its way completely out of the ridge, undersea volcanoes are formed. These volcanoes keep growing taller and taller until their tops are out of the water. These new land formations become islands and island chains. Divergent plate boundaries. One divergent plate boundary is found under the Atlantic Ocean. This is where the North America plate and the Eurasian plate are pulling apart. Scientists believe that long ago North America and Europe were connected, but after pulling apart for millions of years, they are now separated by a vast ocean. The plates are still moving apart today. The area where the seafloor is spreading is called the Mid-Atlantic Ridge. This is the Mid-Atlantic Ridge. Many volcanoes are formed along the Mid-Atlantic Ridge. The island of Iceland contains at least 8 volcanoes. Ivalaku is the volcano that caused all the disruption in air travel in 2010. It is found on the Mid-Atlantic Ridge in Iceland. Hotspots. Volcanoes occur where there are two plates meet. Sometimes they also form in the middle of plates in areas that are called hotspots. A hotspot is a place where magma rises up through the crust and forms a volcano. If a hotspot is in the ocean, the volcano will eventually grow tall enough to become an island. Over time, the different parts of the crust will move over a hotspot because of Earth's plates are constantly moving. Then a new volcano forms. The most famous example of the hotspot is the Hawaiian island chains. Kauai was the first island to form over the hotspot. As the crust moved to the northwest and each additional island was formed. Currently, Hawaii's island is over the hotspot. It is one of the 2 Hawaiian islands with active volcanoes. Eventually, Hawaii Island will move off the hotspot. Another volcano is rising far beneath the surface of the ocean. It is called Lahi, and it's located about 19 miles southwest of Hawaii's island's Kili volcano. Hotspots don't just occur on oceanic plates, they also occur on continental plates. Scientists believe a hotspot is what causes the volcanic activity in Yellowstone National Park. The Hawaiian Islands are volcanic islands that form over a hotspot. Okay, so if you are doing lesson 2, for this, we're going to stop and pause, and I will see you tomorrow. Okay, now we're on our lesson 3, and we're in chapter 2. Fountains of fire. Vents, the top opening of the conduit. Here's a vent. The flank is the side of a volcano. Lava is what's coming out. Craters, an indent in the top of a volcano where the lava flows. This would be the crater. This is an ash cloud. The summit we have to look at this in a 2-page. Okay, the summit is the highest part of a volcano. The conduit, a pipe, that's where the magma travels up to reach the Earth's surface. And the magma chamber is the bottom of the volcano where the magma is stored. So volcano classifications. Active volcanoes, volcanoes that have at least one eruption in recorded history. Dormant volcanoes that have not erupted in historic time but are expected to erupt again in the future. Extinct volcanoes, volcanoes that have not had any eruptions in the last 10,000 years are not expected to erupt again. Okay. Types of volcanoes. There are different types of volcanoes. These stratovolcanoes, cinder cones, and shield volcanoes. Stratovolcanoes often take millions of years to form. Numerous eruptions and layers of ash and lava have built up on their side. They are sometimes called composite volcanoes. Examples include Mount St. Helens, Mount Fuji, Mount Rainier, and Mount Hood. So this is like Mount Rainier, which is our closest volcano. Cinder cones are the simplest and smallest volcanoes. They are relatively short, usually 1,000 feet or less in height, and many of them have a bowl-shaped crater at their summit. Most originated from a single eruption. So this one is on the island of Maui. Lava domes form when the lava that pushes out of the conduit is too thick and sticky to move a great distance. It builds up into a round dome mass of lava. An example of this is the Nova Rupta Dome in Alaska. Mount St. Helens built several lava domes in its crater after it violently erupted in May 1980. Shield volcanoes are built up mostly of lava flows. They are called shield volcanoes because their shape resembles a warrior's shield. These volcanoes are generally very large and wide. Mauna Loa and Kilauea in Hawaii are examples of shield volcanoes. Kelknap, a shield volcano in Oregon. Other volcanic structures. There are other types of volcanic structures besides mountains. These include plugs, mud volcanoes, geysers, fumaroles, and hot springs. Geysers are hot springs that periodically erupt, shooting steam and water into the air. The water is heated by the hot rocks deep in the Earth's crust. Okay, you see this geyser. It's in New Zealand. Fumaroles are openings in the Earth's crust near a volcano. They are hot spots where hot steam and other gases escape. Yellow sulfur deposit often encrusts the outside of a fumarole. Fumaroles are common on active volcanoes. Instead of fumarole activity on a dormant volcano is a clue that there's a drastic eruption may occur in the future. Plug volcanoes are landforms that occur when magma hardens inside the vents of active volcanoes. The magma plugs the vents. Over time, the outside of the volcano is worn away through erosion. Eventually, the plug is all that is left. An example of this landform is the Devil's Tower in Wyoming. We are going to stop here for today, and I will be attaching another video for the other lessons. Have a great day!